we're looking at this sheet on domain and range, okay? Now, yes, we have sketched a lot of these types of functions before. You should be able to recognize some, but some of them you won't recognize, okay? And we're going to purely, like question E, for example, just purely look at we can do it a few ways, but what values could what's under the square root sign be, okay? So we just want to look at restrictions, any restrictions that we can see. So we're not going to do this by sketching. We're going to do this using just looking at the restrictions on the values of x. So looking at question 1a, what can you tell me straight away? That x plus 1 can't equal 0. In other words, x cannot equal negative 1. So my domain is all real x. X is not equal to negative 1. I mean, the other way you can do this. Now, if x can't equal negative 1, the denominator will never, well, the denominator can't be 0. Do you think, so range of y values, you will never ever get 0. It's impossible. All right? So that would be all real y. Y can't equal to 0. Why will I never get 0? The denominator can't be 0. The numerator will never be 0. The only way you can get 0 is 0 divided by something. That's never going to happen. But looking at your, let's just go to the curve sketching thing. You remember, can you recognize that function? What is it? What sort of function is it? Hyperbola shifted 1 unit where? The shift is with the x. Sideways or up and down? Sideways. Where? To negative 1. Quadrants. Guys, is it a positive hyperbola or a negative one? It's quadrants 1 and 3. It looks like this. That's what it looks like. Now, you could put some x-intercepts like, oh, sorry, y, there's no x-intercepts. You could put the y-intercept, which is 1. When x is 0, y is 1. But that is what that looks like. That is a hyperbola shifted 1 unit to the left. And domain, all real x, x is not equal to 1, range, all real y. See how y is never going to be equal to 0, right? The next one, we're doing them first without sketching. Y equals the square root of 9 minus x squared. I recognize that, yes, as a semicircle top half, right? But without knowing that, let's say we did this before we knew what the functions were. What I do know is that 9 minus x squared has to always be positive or 0. All right, I know that 9 minus x squared is greater than or equal to 0. Are you okay with that? You cannot do the square root of a negative number. It's undefined. So in other words, this 9 minus x squared, the values that it takes have to be greater than or equal to 0. So let's have a look. Do you know how to, remember quadratic inequality? Sketch it always. So let's say this is not the question anymore. I'm asking you just to solve this. 9 minus x squared is greater than or equal to 0. That is factorizing 3 minus x, 3 plus x is greater than or equal to 0. Tell me what that is. Sorry, I don't need that if I don't. Isn't that a parabola concave down? Yes? What's its y-intercept? That's what it looks like. It is. It's the x squared, negative x squared curve shifted up 9 units. What are these? 3 and negative 3. That's the graph if I drew the parabola. Like if I drew the parabola, that's it. Now, where is this curve? Do you remember doing this before? Quadratic. In other words, x squared inequalities, you must sketch them. Where is this parabola above the line or equal to the line? Where? Between values of? Right, between values of negative 3 and 3. Now, with the range, it does help if you know what the function is. The range is not 9, by the way. Let's say that x was negative 3. What would you get here under the square root sign? If x was negative 3, don't you get 9 minus 9 is 0, square root of 0 is 0. If x was somewhere between negative 3 and 3, let's say x is 0, wouldn't you get 9 minus 0, square root of 9 is 3? I'm just looking at the range without knowing what the function would look like. And if x was 3, I'd get 9 minus 9 is 0. So it looks to me like the y values ranged between 0 and 3. I can look at x is 1, I get square root of 8. But I was trying to pick the extremities of what would be this value. So my range is from 0 to 3. I will always get positive answers. Now, the other way of doing this, so this is hard, a bit harder to do it this way. So it does help if you know the function. It does help. Let's say you were stuck. You did not know what this is. Do you remember the other way of doing it? What could you do to both sides? Square both sides to say, where did this come from? And then you would say, that's right, that's a circle. That's a semicircle top half. And then you could draw semicircle, radius 3, top half, and then you've got everything there. Now, see this sketch here? This is not the square root function. This is the 9 minus x squared without being square rooted. Do you get it? So that just helps me with domain. But if you're actually able to draw the actual function, right, so it came from a circle, but it's the top half, you'll be able to see the domain is -3 to 3 and the range is 0 to 3. Okay? Now, 1c should be fine. That is a hyperbola. Okay? Or we can just look at it like this. Obviously, you're not allowed to have x. We know that x can't equal 0. That's our restriction. So the domain is all real x. X can't equal to 0. And the range, if x is not equal to 0, y, the numerator, is never equal to 0 as well. So y, sorry, not y, the numerator 12 will never be 0. You can never get 0 as a value for y in this function. Does that, because you're not allowed to do 12 divided by 0. You can do 12 divided by anything else. Y will never be 0. So the range is all real y. Y is not equal to 0. And just with our knowledge of curve sketching, y equals 12 on x is in quadrants 1 and 3. It's a hyperbola. It's just further out from the axes, that's all. All right? And if you had to sketch, you would just put in a point when x is 1, say y is 12, for example. All right? But we're trying to do these without sketching first, and then we can sketch them, all right? The next one, D, y equals x over x squared minus 4. Now, what do you think we should do here? Well, the problem is the denominator, isn't it? That x squared minus 4, what do we know? That there's no restrictions on the numerator. The thing is that x squared minus 4 can't equal 0. Yes? What's the solution to that? You can make it that x squared can't equal 4, or you could factorize that as x minus 2x plus 2 can't equal 0. In other words, x can't equal plus or minus 2, positive or negative 2. Or we could have factorized and written x minus 2 bracket, x plus 2 bracket can't equal 0, and still get the same answer that, now you would only ever do it this way if it's equal. If this is an inequality, you would never do that. So really, I mean, we probably should be doing that. Can't equal 0. Do you know what I mean? Because if this was an inequality, you would never say x squared is greater than 4 or something. You can't do it like that. Quadratic inequality must be sketched to find the solution. Okay? But if it's equal to 0, yes, you can just find the solution. So we're thinking domain all real x except for x not equal to plus or minus 2. Now the range, could the x be 0 up here? Can x be 0? It can. 0 divided by -4 is allowed. If x is 0, that's the y-intercept of this function. It's allowed. If x is 0, 0 divided by 0 minus 4, 0 divided by -4 is 0. So y will be a value in this function. You can have y. You can't have x is positive 2 or negative 2. So, so you've got the fact that you can have 0 is fine. You're going to have all real y. I can sketch that one for you. We are going to learn how to sketch these. This is actually a little bit mean, this one being in here at the moment. But this is a 3-unit sketch. See, if this was, yeah, this is a 3-unit sketch whenever you've got x squareds and that on the denominator. All right? But just by looking at that, look, x definitely cannot be positive and negative 2. Just by looking at that, you always check if y could be 0 somehow, but it can, because x is allowed to be 0 here. But in the one before, the denominator x can't be 0. Do you get it? But here, if I put x is 0, the denominator is not 0. You're allowed to have the numerator 0, just never denominator to be 0. I'm not going to sketch that one because that would take me about 10 minutes. All right? We're doing that next lesson. Y equals the square root of x squared minus 1. This one, it's not a circle. It's not a semicircle. What can I do? Let's just look at it in terms of what x could be. Just tell me something about the square root. What's under that square root sign? X squared minus 1. What sort of values can it have? Greater than or equal to 0. Now, this is a quadratic, is an x squared function, inequality with greater than or less than. You cannot just say x squared is greater than or equal to 1, x is greater than or equal to plus or minus 1. You've got to sketch it. So, x minus 1, x plus 1, greater than or equal to 0. Do you remember we sketch? 1, x could be, and you solve for equal 0. Do you remember this? Is this concave up or down parabola if I want to sketch that? This is what it looks like. This is a concave up. If I was sketching x squared minus 1, not sketching this, sketching, I know that x squared minus 1 has to be greater than or equal to 0. X squared minus 1 is a parabola with x-intercepts -1 and 1, greater than 0, equals 0, less than 0. What values of x am I allowed? X is less than or equal to -1. X is greater than or equal to +1. Now let's just sort of see the values that we're going to get. Let's say if x, let's do the positive ones. Let's say x was 2. Let's say x was 1. What do you get for y? All right. You know, y, so our domain, that's our domain is that you can write it two ways. Yeah, our domain would be x is less than or equal to 1, x is greater than or equal to 1, or you could say all real x except for so you could write that as your domain, or you could write it as all real x, comma, but you're not allowed to have -1 to 1. Do I put equal to sign here or not? Oh, no, you can't do it this way because I can't put not equal to. Do you know what I mean? I can't do that. Leave it the other way. Sorry. I can't put not except for those. I think it looks better like that. Now, let's say if x was 1, what would you get here for y? 0. If x was 2, you'd get square root of 3. If x was 5, you'd get 25 minus 1, square root of 24. It's getting bigger, isn't it? Do you get that or not? What sort of y values do you think you're going to have? Just looking at it. Y is the square root of something. It's got to be what? Positive or 0. No, you can't get a negative. When you square root something, you don't get a negative. Never. I know you're saying, but if x squared is this, you get plus or minus the square root. The square root answer does not give you the negative. So if you square root something, it's always positive. Sometimes we put plus or minus in front of that square root. All right, but no matter what value of x, look, whether I substitute a positive or a negative x value, won't x squared always be positive? So you're doing the square root of 0 or the square root of a positive number. Your answers for y are always going to be 0 or greater than 0. That's your range. Now, if you want to sketch it, we're doing this later in the year. You know when I had the circle version of this, semicircle, what did I do? Where did this function come from? Tell me. What should I do? Square both sides. Let's have a look. Ooh. No, you don't know this function. We don't know y squared minus x squared is -1. We can't sketch it. We could sketch it by plotting values, all right, but that's not a typical function that we know, all right? If it was y equals x squared minus 1, we could have sketched it. That would have been a parabola shifted down 1 unit, but it's not. This is not half a parabola, all right? So forget that. You just have to do that one that way. All right, f should be fine. Y equals 1 over x minus 2. You can see there, do you know what that is? It's a hyperbola shifted. So what's the domain? All real x cannot equal what? 2. And the range, except, yeah, you'll never get 0 for an answer. Y not equal to 0. And it is a hyperbola shifted 2 units to the right, and it's in quadrants 1 and 3. That's where it would be. That's what it looks like. Make sure you put arrows, and of course you would plot a point. When x is 0, this is -1/2. Okay, we'll keep going. G. Is this the positive square root of, or is it the negative? No. 1 minus x squared. What's this one? Yeah, it's a semicircle. You recognize it? So you do recognize it as a semicircle, radius 1. But let's say you didn't recognize it as that. I know. Look, the domain is easy to work out. If you didn't recognize it as that, you tell me what 1 minus x squared, what sort of values it can take on. Can it be less than 0? Can it be 0? And it's positive. Can be positive. So 1 minus x squared is greater than or equal to 0 if we were just looking at it and we didn't know that it was a semicircle. What else can you do now? X, 1 plus x is greater than or equal to 0. Is this a concave up or down parabola? Down, shifted up. Looks like it's shifted up 1. You know, negative x squared plus 1. That's 1. That's -1. Are we good? So tell me which values are greater than or equal to 0. Through to? Yeah. So, and we saw that there anyway. So the domain is -1 less than or equal to x less than or equal to 1. And the range, what you would do, you can just substitute some values in. If x was 1, you'd get 1 minus 1 is 0. Choose somewhere in -1, you get the same answer because it's squared. And x is 0 would give you the lowest, like the biggest value here. Do you get it? If you put x is 1 here, you get the smallest value under the square root. If you put x is 0 here, you get the largest value you'll ever get under the square root. So when x is 1, you get square root of 0, 0. When x is -1, you get the same. When x is 0, you get square root of 1 is 1. So it's from 0 to 1. But we can see that over here in the graph. All right? Tell me what x can't be.
0.
So domain, we're thinking all real x. X can't equal 0. What about the range? Yes, very good. X squared, so what sort of y values could we have? Well, x squared is always positive. So I'm going to go x squared is always, has to be greater than 0, can't equal 0 as well. Do you see that? You're not allowed to do 1 divided by 0. X squared is always positive because you're squaring something, you'll always get a positive answer. So really for the range, that's not the range, that's just, I'm saying, well, x squared has to be positive. We can't allow it to be 0. What sort of y values would you get? 1 over something positive. 1 over something positive. Y is what? Greater than 0. Let's have a quick sketch if we want. Let's substitute some values. When x is 1, y is? When x is -1, 1. What about when x is a half? 1 divided by a half squared is 4. 1 divided by a quarter is 4. Look, it looks like this. And then the -1 would go there. So we've got a half 4. We've got 1, 1. And let's just try when x is 2 or something. What do you get? When x is 2? A quarter, isn't it? There we go. If you're not sure what to do, substitute a few values. -2 would give you a quarter as well. That's what the graph looks like. All right, just by substituting. But we knew that x can't equal 0 and that y is positive without even knowing what the graph looked like. Equals 2 to the power of x. Do you know what it looks like? It's a? Yeah, and you look, you know what? Yeah, that's what it looks like. Cuts through at 1. So what's your domain? All real x and range. Y is greater than 0. Okay, and y equals 6. A quick sketch up here. What have you got? What's the domain? Is there any restriction on the x values? Look across. X could be anything. You get, see, this is the point 0, 6, 1, 6, 2, 6. So the domain is all real x, and what's the range? And the range is y equals 6. Consider each one separately. Tell me about x minus 5, that it has to be greater than or equal to 0. In other words, x has to be greater than or equal to 5. That's using that. What about this? What about 2x minus 15? Cannot equal what? 0. In other words, x cannot equal 15 over 2, or 7.5. Is x is greater than or equal to 5, x cannot equal 7.5. So if I was to sketch that on a number line, I'd have 0, 5, 10, 7.5 here. I'd draw it like this with a hole there. Not that, you know what I mean. Like, you'd have x is greater than or equal to 5 and 7.5 is excluded with a circle. But it can be anything else. That would be a visual of it. And let's look at B, 2b. Y, so y equals 1 over x plus 1 over x minus 1. So we're going to do the same thing. X can't be and x can't be. So it's just normal domain. So give me the values. Domain, all real x except for what? X can't equal 0 or 1. That's it. We don't want the range. Oh. I don't think you'd get y is 0 with this one. I think you could get y is 0 with this one because you could get, if x was what? No, you can't. Oh, you might. One of them might be positive. One might be the exact positive or negative of the other. They're not asking for the range anyway. So, because this is the entire function, I could rewrite that function like this. 1 over x plus 1 over x minus 1. Common denominator, isn't that x minus 1 plus x over x bracket x minus 1, which is 2x minus 1 over x bracket x minus 1. So that's actually what the function is. So I'm still not allowed to have x is 0 or 1. Do you get it? So yeah. Okay. So they're the same function. So there might be some conflicting. So we've got 2c, y equals the square root of x plus 2 plus the square root of x minus 5. Now from the first one, x plus 2 is greater than or equal to 0. So x is greater than or equal to negative 2. And with the second one, x minus 5 has to be greater than or equal to 0. So x has to be greater than or equal to 5. Now, this is one single function. Which one are you going to choose? Which one overlaps? Like which solution is good for both the first part of the function and the second part of the function? Which one? No, you can't put negative 2 into this second part. So, which domain will satisfy the entire function? Yes. So the largest possible domain, possible domain that is x is greater than or equal to 5. It's the only domain that works for the whole function. Do you get that? X is greater than or equal to negative 2 will not work for the second part of the function. Do you get it? So the domain for that entire function would be x is greater than or equal to 5. All right, and 2d, y equals the square root of 2x plus 1 minus the square root of 6 minus x. 2x plus 1 is greater than or equal to 0, and 6 minus x has to be greater than or equal to 0. So x is greater than or equal to negative a half, and this one is telling me that, what? Careful. You know you can just take the x over. That's the easiest way, like that. That way you're not multiplying or dividing by a negative. However, if you want, you can go 6 is greater than or equal, you can go negative x if you want, but I wouldn't do it this way. So you can go 6 minus x is greater than or equal to 0. See, this way is easier, isn't it? Just taking that over. You've got 6 is greater than or equal to x, or x is less than or equal to 6. Now, if x is greater than, I'll show you over here in a minute. With this one, you could go negative x is greater than or equal to negative 6, Now multiplying through by -1, x is less than or equal to 6, if you want to do it that way. You okay with this? So, tell me, how do I write that? It's in between. X is in between -1/2 and 6. X is bigger, greater than or equal to -1/2, but less than or equal to 6. See? So, you've actually got the number line. That's what you've got. You see? So the solution is -1/2 is less than or equal to x, which is less than or equal to 6. That's what we've got. And if you want to sketch the top one, you've got -2 down here and 5 there. You've got x is greater than or equal to -2, but x is greater than or equal to 5. And the only place where both hold is x is greater than or equal to 5. X squared plus 1 can't equal 0. X squared, but it'll never be 0, you know. Do you see that? You'd have to have x squared is -1. That'll never happen unless we're doing complex numbers in extension 2. So that denominator is never going to be 0 anyway. No problem. X can be whatever it wants. Can't it? Because look, do you see? If x is -1, you'd get 1 plus 1 is 0. Look, this one I'm going to write. X squared is positive, greater than or equal to 0 for all x. That means that the denominator is greater than or equal to 1. Oh, very interesting. So x squared is greater than or equal to 0 no matter what value of x you choose, yeah? X squared plus 1 therefore must be greater than or equal to 1. The value of that denominator will never be less than 1. Do you agree with that? Because x squared could be 0. And even if x is -5, you're going to get 26 on the denominator. So do you think this function could ever be... So let's just look at our domain. Didn't we just say you can have any x that you want? All real x. What about the range? Do you think you're ever going to have 0? Do you think you're ever going to have anything bigger than 1? You're going to have, all right, if x is 0, you're going to get 1. Look, we'll just watch. If x is 0, you're going to get 1, aren't you? 1 over 1 is 1. If x is 1, you're going to get 1 over 1 plus 1, a half. If x is 5, you're going to get 1 over 26. You're never going to get 0 as an answer because the numerator is not 0 and the denominator can never be 0. You're not allowed to have denominator 0. Do you think you'll ever get a value bigger than 1? You can't. It's 1 over something bigger than 1 all the time. Except for when x is 0, you get 1 over 1. Well, I'm saying that the denominator is always greater than 1, so 1 over 100. You're always going to get a decimal or a fraction between which values? You're going to approach 0. What about when x is 10? You get 1 over 101. That's small. That's close to 0. You're never going to get 0. So what is it? 0. It doesn't include 0, but does it include 1? Can you get 1? Oh, that's a good one. Okay, 3G. Y equals 1 over the square root of x minus 2. That's extension 1. That's harder 2 unit there. All right? Anything harder could be in a 3 unit paper, all right? What about the denominator? Can that x minus 2, it's got to be positive, we know that. But can it be 0? No, because you can't do 1 divided by 0. So normally with square roots, you just say whatever's under the square root has to be greater than or equal to 0, but we can't put equal 0 this time. Do you know why? Because it's sitting on the denominator of the fraction. See, the denominator can't be 0. So this x minus 2 has to be greater than 0. Now let's go back and look up here. See, these were greater than or equal to 0, greater than or equal to 0, because you can do the square root of 0, but you can't do the square root of 0 when it's on the denominator, because you can't have a denominator of 0. So in this case, x minus 2 is greater than 0, not greater than or equal to 0. Do we know why? Because you can't do 1 divided by 0. The denominator can't be 0 and it has to be positive. So that gives us just greater than 0, not or equal to. Greater than 2. So x has to be greater than 2. Let's just sort of see the values we'd get here. Now if x was 2, well we get 0, but that's not allowed. If x was, say, 4, we'd get 1 over the square root of 2, which is something small. If x was 6, yeah, you'd get a half. All right, so we're going to get fractions. We're getting values bigger than 0, right? How big is it? As x gets bigger, aren't we just going to get smaller and smaller fractions? Okay, similar to this. I think it's between 0 and 1. As x gets bigger, you can only if this was 1. What's 3? If x is 3. 3 minus 2. Do you see? If x has to be bigger than 2, but if x was, what was if x was 2.5? What's the square root of a half? That's small. But if x was 3, what do you get for y? Don't you get here 1? 1 over 1. You can get 1, right? If x was 2.5, 1, what's 1 over the square root of a half? Actually, it could be bigger than 1. Have a look. Please, I think it is actually. If x was 2.5, what's 1 over the square root of a half? Yeah. And what was if x was like 2.1? 1 over the square root of 0.1. See, 1 divided by something really small is something quite large. What's 1 over the square root of 0.1? Etc. All right. Now we know that we can get y is 1. We know we can get values of y greater than 1. Let's go for some bigger values like x is 10. We get 1 over the square root of 8, which is 1 over 2 root 2, which is... Actually, give me a fraction for that. 1 over square root of 10. That's fractional. Do you know what I mean? If x... I'm just going to put x is 102. Don't you get 1/10? Because 102 minus 2 is 100. Square root of 100 is 10. All right. What sorts of values do you think you've got? Just greater than 0. So this was a bit tricky there to make sure that we came in close to the 2. You know, like we don't just start at x is 3 and 10 and 100. We've got to go for values of x closer to 2 as well and check. Do you see? So in other words, the domain is x is greater than 2, but the range is y is greater than 0. Yes, because look, we're getting small values here. Y equals x over x plus 4. All right, immediately what can you see? That. Yeah, x plus 4 can't equal 0. X can't equal -4. Then you ask the question, all right, so we know, you know, our domain is all real x. X can't equal -4, right? So we had x plus 4 can't equal 0. There's our domain. Now our range. Look, you're pretty much going to have... Do you think you could have negative answers? Yes, you can. -1 over 3. If x is -1, that's allowed. You can have negative answers. Of course, you can have positive answers if x is 1. Let's ask the question, can we ever get x is 0? I mean, sorry, can we ever have y values of x is... Can we ever have an answer of 0 for this function? Yes, if x is 0, you get 0 over 4 is 0. Looks like we can have positive, negative, and 0.
All real y.
All real y. So that's what you want to be looking for. You know, can I get positive answers? Can I get negative answers? Can I get 0? You try them all out, and then you think, no, I can have all those. All real y. Unless there were some square roots, there's restrictions. Largest, question 6, largest possible domain and range. Oh. Do you think X is allowed to be anything? Yeah. All right. Let's just start with that. So the domain, it's got to be all real X. I mean, just look at it. X can be positive, it can be 0, it can be negative, no problem. The range, but now, we know that this second bit is always going to be positive or 0. So we know that that will be greater than or equal to 0. No matter what value of X you put in there, it's always greater than or equal to 0. And this X bit here can be positive, negative, or 0. So you could still get, just wondering if we had like X is negative 5. You know when X is, actually, let's just be careful. Let's just, I think the answer is 0. You only get 0. Let's look. Let's just try. Sorry about that. But let X equal 5. What do you, negative 5. What do you get? Negative 5 plus 5. What do you get? 0. You get Y is 0. So any negative values you put in there, you're going to get 0. Do you get that? If X is negative 10, you get negative 10 plus absolute value of negative 10. Wait, but what about the positive values? So that's for all the negatives, you're going to get zeros. So for X less than 0, the range Y equals 0. Do you get that? For any negative value, Y will equal 0, right? When X is 0, so when X is 0, Y would be 0. What about for some positive Y values? Let's say Y was 1. What's your answer? Sorry, X is 1. Sorry. When X is 1, don't you get Y is 2? When X is 2, Y is 4. When X is 3, Y is 6. Do you see? So when X is greater than 0, it looks like Y will be whatever 2 times. Anyway, it doesn't. Look, you're going to get, Y will be positive, won't it? It'll be positive.
X is less than 0 and Y equals 0. You can just write
What's your range? Yeah, no. What's your range? Greater than or equal to 0. For negative values of X, your range, you'll always get Y is 0. When X is 0, you'll always get Y is 0. But if X is positive, Y is positive. It's going to be double your X value. So your range is Y is greater than or equal to 0. These are good questions. 6D. Let's work with the denominator. 3 minus X, what? Yes. Has to be, because of the square root, it's greater than or equal to 0. But because of the denominator, it can't equal 0. So that just leaves me with greater than 0. Do you get it? Square root, greater than or equal to 0. Denominator can't equal 0. So we're just left with greater than 0. So that means what? Or X is less than 3. Now, let's look at some values. X can't be 3. Let's say X is 2. Oh, be careful. Let's do 2.5. See, we don't want to make that mistake of doing, do you know what I mean? Of starting at 2. Because let's say X was 2. What would you get? So I'm going to go X is 2 and Y will be 3 minus 2, that's 1. 1 over 1 is 1. 1 over the square root of 1 is 1. What about if X was something like 0? 1 over the square root of 3, that's a fraction. What happens if X was negative, give me a nice number, negative square root of 4, negative 1. What happens if X is negative 1? 3 minus negative 1. That's 4. Square root of 4 is 2. You get a half. What's our next one going to be? Negative 6. 3 minus negative 6, that's 9. 1 over the... a third? All right, what's our next square number? Whatever. What do you think they're going to approach? Ever going to be 0? Is it ever going to give you 0? No. You're never going to get 0. What's the next one? Negative 22? A fifth. Right? That's enough down there. Right? Let's come back up here. Let's do 2.5, 2.9. Got it? X is less than 3. Let's do 2.9. So 1 over Now, that's the square root of, what's 3 minus 2.9? It's 0.1. 1 divided by the square root of 0.1, we did that before, which was, or 3 point something. 1 over the square root of 0.1. I've got a fifth, a third, a half, 1, 3. Yep. So your domain is just x is less than 3 and your range is y is greater than 0. See, some people might think y is just going to be greater than 1, but it's not. No, never be 0 because 1 divided by always some number. Okay? Now, the reason I'm checking these, some people might think it's just y is greater than 1. Sorry. Actually, that y can't be bigger than 1, but it can. Some people might think y only goes from 0 to 1, but it can be higher. That's why we're doing those values between 2 and 3. Okay, and the last one, what can x not equal? 0, I think. Yeah, or real x. X can't equal 0. Now, no matter if, now let's say x was negative, let's try a negative value and a positive value. If x was negative 5, what would your answer be? Negative 5 over 5 is negative 1. If x was negative 10 over 10 is negative 1. So it seems that when x is less than 0, y is negative 1. What about when x is greater than 0? What do we tend to get? Not, yes. All the time. But one was, and if x was a half, you'd get a half over a half. So, oh, this is a weird one, isn't it? So therefore, your domain is all real x. X is not equal to 0. What do you think your range is? Y is either 1 or negative 1. Seem to be the only values we're getting. Plus or minus 1.